11.3 logarithmic functions. It's MA912, AR.5.8 and 5.9, MA912, F.1.2 and 1.6, MA912.NSO.1.6. We're going to evaluate and graph logarithmic functions, evaluate and graph natural logarithmic functions, and use the change of base formula to evaluate logarithms. The definition of a logarithmic function says that let a and x be positive real numbers such that a does not equal 1. The logarithm of x with base a is denoted by log sub ax and is defined as follows. Y is equal to log sub base a of x if and only if x is equal to a to the y power. The function of f of x equals log sub ax is the logarithmic function with a base a. Note that the inverse function of f of x is equal to a to the x is f inverse x equaling log a of x. So for example 1, they want us to evaluate logarithms. So they gave us log sub base 3 of 9. So what we're doing is we're trying to figure out 3 raised to what power gives you 9. So this is basically saying 3 to the power of x gives you 9. So we know that 3 squared is equal to 9. So log sub base 3 of 9 is equivalent to 2. On the next one says log sub 4 of 2. So we rewrite it as 4 to the x power equals 2. Well, 4 to the negative half power is going to be equaling 2 because if I take the square root of 4 in a fraction format, I come down. So then my answer is going to be log 4 of 2 is equal to the 1/2. Now, on the next one says log sub 5 of 1. So it's saying 5 to the x power gave you a value of 1. 5 to what power gives us 1? Well, 5 to the 0 power gives you 1. So log 5 sub base of 5 of 1 is equal to 0. Now we see log base 10 of 1/10. So it's saying what log 10 raised to what power is going to give us 1/10. So we have 10 to the power of x gives us 1/10. Well, if I write 10 to the first power, that is 1/10. So log base of 10 of 1/10 is equal to -1. Then we have log sub base 3 to the -1 power. Okay, it's saying 3 to what power is going to give us -1? This is not possible. The 3 raised to no power is going to give us -1. Okay, the properties of logarithms say that let a and x be positive real numbers such that a does not equal 1, then the following properties are going to be true. Log sub base a of 1 is equal to 0 because a to the 0 power is 1. Log sub base a of a is equal to 1 because a to the first power is equal to a. Log sub a of a to the x is equal to x because a to the x gave us a to the x. The logarithmic function with a base 10 is called the common logarithmic function. On most calculators, it is denoted by the log key. You will see a key that says the word log. So example 2 wants us to evaluate common logarithms. So first thing we start out with, referring back to our original notes of properties of log, it says log base 10 of 100. So it's saying 10 to what power is going to give you 100? Well, 10 to the second power gives us 100. So log base 10 of 100 is 2. On this one it says log sub base 10 of 0.01. First thing I'm going to do is I'm going to rewrite this as log sub base 10 of 1 over, this is the hundreds place as 100. So now we're seeing 10 to what power is going to give us 1 over 100? Well, that's actually 10 to the -2 power is going to give us 1 over 100. So log base 10 of 0.01 is -2. Example C and D will not have an actual answer that can be done algebraically because there's no number that gives you 10 raised to a power that's going to give you 5. So that's where the calculator is going to come into place. So you're going to use the calculator, and now Depending on the calculator model you have. If you have a Texas Instrument one, you're going to hit the log key first. It is base 10, so you're going to hit the log key. It's denoted by the word log. Hit log, and it's a 5 is what we want to find the log of. And it's going to tell us it's 0.69897. So normally we're going to go 3 decimal places. So we did log of 5 in the calculator, and it was 0.699 because that 9 makes that 8 become a 9. Then we see log base 10 of 2.5, and you're going to do the same thing. This is the log of 2.5. So in the calculator, hit the log key, type in 2.5, close it with the parentheses, and hit enter. And we get it as 0.3979, so 0.398. In example 3 and 4, it's about graphing the logarithmic functions. So they gave us 2 functions and they want us to graph them on the same plane. So it's f of x equals 2 to the x, and g of x is equal to log sub 2 of x. So we're going to start with f of x equals 2 to the x, and I'm going to use a table. So it's saying 2 to what power gives us negative 2? Because the x is negative 2. So you're saying 2 to the negative 2 power, well that's 1/4. So I'm a point of 1/4. The next one's saying 2 to the negative first power. Well, that is 1/2. 2 to the 0 power, that's a 1. 2 to the first power, that's a 2. 2 to the second power, that's a 4. 2 to the third power is an 8. So we have our points, our ordered pairs, and then we're going to plot our points. So when x is negative 2, the y component is 1/4, about a quarter of the way up. When x is negative 1, I'm at a half, I'm halfway up. When x is 0, I'm at the 1 line. When x is 1, I'm at 2. When x is 2, we are at 4. When x is 3, we are at 8. And then we kind of sketch our line in. And it's going to keep going up exponentially. Now, we need to remember that log sub 2 of x is the inverse of 2 to the x. It's the inverse of 2 to the x. So, if we are reflecting it, you're going to reflect your graph over the y equal to x line. So imagine an imaginary dashed line forming right here, and it's going to be a reflection of this, which means if we invert our values, so it's a reflection, when x is 1/4, I'm at negative 2. When x is 1/2, we're at negative 1. When x is 0, we're at 1. So it's doing this. It is hugging the y line as a mirror image. It is going to be a mirror image. Remember, f of x equals 2 to the x and log base 2 of x, they are inverse functions of each other. The natural log function says that the function defined by f of x equals log sub base e of x is known as ln of x, where x is greater than 0. So some properties of the natural log state that let x be a positive real number, then the following properties are going to be true. ln of 1 is equal to 0 because e to the 0 power equals 1. ln of e equals 1 because e to the first power is going to be the letter e. ln of e to the x is equal to x because e to the x equals e to the x. In example 5, we want us to evaluate natural logs. So it says ln of e to the second. So we need to remember our properties that says e to the x equals x. So e to the 2 power is going to equal 2 because 2 is in the position of the x. On ln of 1/3, first we write it as e to the negative 1 power. So now I see to the negative 1, that's going to result in negative 1. There's another formula called the change of base formula. It says let a, b, and x be positive numbers such that a does not equal 1 and b does not equal 1. Then the log sub base a of x is given as follows. So log a of x, sub base of x, is equal to the log of the base value to the times x over the log of the base value of a. Or log of a to the x is ln of x over the ln of a. The easiest way to do this is actually apply it. So in example 7, they want us to change the bases to evaluate logs. So for the first one, we're going to use common logs to evaluate log base 3 of 5. So what we're going to do is rewrite it in base 10 form. So log base 10 of 5, because 5 is the first number, over the log base 10 of 3. So using the calculator, we're going to do the log of 5 divided by the log of 3. And it results in 1.46497. So it gives us 1.465, because I went through decimal places. So here's another way of going about it. You can find the log of 5 by itself first, and know that it's 0.6989, and then find the log of 3, and then take the log of 5 value results and divide it by the log of 3 results. Or just stick in log of 5, close the parentheses, hit the divide bar, log of 3, close the parentheses, and you end up with the same result. On the part B one, they want us to use the natural log. So it's not the log key, it's the ln key. So on your calculator, there's an ln key. So we're just writing it as log. Normally we would write log 10 of 2, but we're going to use the ln. So we're going to say ln of 2 over ln of 6. So in the calculator, the ln key is right below the log key. So you're going to hit ln of 2, close the parentheses, divided by the ln of 6, and close the parentheses. And it results in 0.3868. So we're going through decimal places, so 0.387.